Okay. Okay. Welcome, everybody. I'm Gail Reynolds. I'm the session monitor here. Thanks for attending. Scott will take over in a second. I just ask that for questions, we'll do them at the end of the session. And if you can type them in the Q&A part, because people tend to do all sorts of things in the chat window, like say hi to one another and things. So questions, Q&A, we'll take them at the end. So enjoy the webinar.
Thank you very much, Gail. Gail, can you hear me okay? I'll take that as a yes. So my name is Scott Genzer, and thank you very much for joining for this webinar on using facial recognition tools to identify unnamed ancestors. I want to very briefly thank the editors of Avutenu, particularly Sally Ann and Erwin, who encouraged me to write this article, well, maybe 6-9 months ago. And I would not be here if it was not for them. So I wish to thank them very much for that. And with that brief introduction, I would like to get right to it. We have a pretty tight timing here, and I really want to get to the details. And here's the idea. So I've been doing genealogy for probably 20-something years. And what I've always found interesting about genealogy is we focus so much on the what I call structured data, the names and birth dates and all these documents. And we've always had pictures, but the pictures always seem to be just add-ons. We just, we crop them, we put it in our tree, but we don't really use them, or at least not to the best of my knowledge, to actually use it as a way to do genealogy research. The only way that people can do it is, of course, you could lay them out all on your table and try to match them like a big game of concentration. That's really difficult. So I work, my day job is I'm a data scientist with a company based out of Boston. And we do a lot of work with artificial intelligence. And it occurred to me one day that we could use some commercial facial recognition software to see if we could tackle this. And so it just sort of dawned on me one day, and I started experimenting a little over a year ago, February of 2019. And so once we add them to a tree, I was wondering if we could do more with that. And so here's how I started. So I've been working with this museum at the town where my father's family come, which is in Mielec, Poland. And they have a museum, and they have a large collection of photographs of Jews that lived in this town. And we were going back and forth, and they said, well, we have these pictures, but we don't know who they are. There was no writing in the back and this kind of thing. So I considered it an interesting challenge, and I thought, I wonder if I could use these facial recognition tools in order to identify these people in these pictures. And so what I did was proceed on a sort of a journey of using the basic concepts of machine learning and facial recognition. If you don't know what those are, I'm going to get to it in a minute. But the idea was initially just to identify these pictures, these people for these museums. And it sort of just snowballed from there. So I'm going to sort of walk you through this. I'm going to try to keep it at a pretty high level. I'm doing a screen share, so I can't see your questions, but I assume they're there. And Gail's going to hopefully yell at me and say, hey, stop, and we have questions. And Gail, I've left some time at the end, but I'm just going to keep talking as if you're listening to me. So first step is really in order to do this, you need a large collection of known photographs. And that's, to be honest, the technology is not the hard part. This is the hard part. You need a lot of them because you can imagine, otherwise it's a needle in a haystack, and this computer helps you solve the problem, but you need the pictures. And so what I started to do was go through all the places where I had found records of people from Mielec, Poland, that had photographs. And so, for example, this is Ancestry, but you can get these records anywhere. These are the emergency passport applications. And on the backside were pictures. So I simply went and cut and copied them, put them in my hard drive, and then I started labeling them. And so if you see this, you're going to see some ID numbers and this kind of thing. This is, geez, I use Reunion, which is my family tree software. And so I just keep an ID number. And you're going to see later that labeling them is really important. So I have a system that I came up with, which is the Reunion ID, and then surname, given name, and then sort of where it's from. You'll notice I use underscores here And that's purely because computers don't like spaces. So I went through. So I found other records that I knew about in the Holocaust Museum. These were these 1941 census, I believe, in Krakow. And they also had very nice pictures. And once again, all I did was grab the documents, cut them, and create these file names. Same thing in Yad Vashem. Everybody knows these records here. There is an image, though, often either on the testimonial, or Yad Vashem, I think, has some newer ways of displaying the picture. Sometimes if you load the page, they are sometimes below the testimonial. Sometimes it's an additional scan. It doesn't matter. So I just did it, and I would crop it. And once again, I would just label it like that. So I started doing this more and more and collecting this large number of people's faces from Mielec and the region around it. So, for example, here you can see, for example, if I go back, this Genealogical Allweis was from Yashlane, which is a small town outside of Mielec. So I knew Yashlane was close by. Same thing with Radomish. This is Radomish Wielki, which is a decent-sized town in the same powiat as Mielec. If you don't know what those are, if you don't do research in Poland, so it's Poland's divided into counties, and just like any other country, and then we have towns, and so Poland has a similar government structure. So Mielec is sort of the county capital, and then there's a lot of little shtetls around there. So this is from the Yisker book from Radomish. Radomish had an amazing Yisker book that they put together after the war. So you can see this is Mendel, Iceland. Just so you know, my Hebrew is not great, but it's enough to read names. And then when I was in Mielec one time, I ended up going to a local museum. So this is the Oborsky Palace Museum. It's part of Mielec. It's a local Polish museum. And I went in there, and just similar to a lot of you, when you go to these towns, I said, do you have any records? They said, oh, yeah, do you want these? And they were hundreds of basically city council identification records. So they would apply for a ID card, basically, and they all had these beautiful photographs. So I kept going through these and just cutting them and labeling them and cutting them and labeling. And when you're all done, you end up on your hard drive with a large number of these, a large number of them. I prefer to use JPEG formats, but you know, different people can do different things. But you need a large number. Otherwise, it's not really useful. You're going to get a lot of just nothing because you can imagine you just need a large collection to match. So I spent most of my time not doing any computer stuff, but simply collecting pictures, organizing them in a way that I knew would be useful later on. So that's really step one. So step two is to break up your, what I call your mystery photos, whatever you want. I showed you the one in the beginning. I'm going to show it to you again, into individual headshots. And you do that in the same way. So for example, this is the picture that I'm starting with. So this is the picture from the museum. And I simply go and take my computer and crop it all into individual headshots like this. None of this requires really any fancy computer skills. You just have to have a lot of patience and keep cutting pictures. And I'm actually going to show this to you in a live demo in a little bit. So here's where the technology comes in. And I'll get to this a little bit later, but basically in this day and age, facial recognition is what we call a software as a service. You don't actually have to program it anymore. I personally have been using Amazon Web Services, AWS. They are, it depends on who you talk to, but I would probably say they're probably the largest cloud provider in the world. You all probably use Amazon Web Services every day, and you have probably no idea. From what I heard, Amazon recently makes more profit on AWS than they do in their retail stores. Amazon's a cloud provider. I'm not going to go into it. But the important thing here is that AWS has what we call a software as a service. Lots of them, actually, lots and lots of them, including cloud storage, and a service which they call Recognition with a K. And if you know how to use some coding and some skills, AWS is not designed for lay people. It's really designed for coders to embed these technologies in their websites, in their software. They're what we would call in the tech world, they would call me a back-end service. They're not a front-end service. They're not the kind of stuff you would see. It's all the stuff hiding in the back end. It's like if you have a car, it's the company that makes all the gas caps. Like, you're not going to go and find, you don't know what company made your gas cap, but there's some company that makes them. Same thing with AWS. So anyway, So if you have a computer and you know how to use either Python or you know how to code on the command line, you know how to use some of these tech tools, you can learn how to talk to this service, basically. So this is how I started. I started playing with this, and I started putting all the pictures in cloud storage. In AWS, they're called buckets, and sending them to this cloud recognition service that, again, I'm not coding this. This is literally what we call in the tech world. This is, quote, out of the box software. And I'll talk about some limitations of that in a minute. And I got results, and the results were mind-blowing. Absolutely. Considering that this was out of the box, AWS did not build this for genealogy purposes. They built this for not nefarious things, but they built it to make money. Lots of reasons why you would use facial recognition. You can think of your iPhone that goes and looks at your Face ID, this kind of thing. It's just to go and sell stuff. So I started playing around with this, and this was the picture I started with. So if you look at the father here and you send it to AWS, the first thing that it does is creates what's called a bounding box. It identifies the bounds left, right, top, and bottom of the face itself. How does it do it? In the handout section, I have the PDF of the article I wrote on Avutenu, but the basic idea is the way they do it is they have humans go and look at thousands of faces. It's probably the most boring job on the face of the earth. And they say, okay, this is a face. Please click on the top of the face, the bottom of the face, the left of the face, and the right of the face. And they get paid a couple pennies. You can go look it up. People do this for a living. Lots of people. It's not very exciting work, but it's money. And AWS will pay you to do this. And what they're doing is creating what's called a ground truth. They're creating, what we say is training the computer to identify the face. And the first thing they do is find the bounding box. Then they hire a lot more people to train the computer to find what's called landmarks. So they find the eyeballs, they find the bridge of the nose, the left, right, center of the nose, the mouth, they find the cheekbones, all sorts of what we call landmarks. And they send the computer thousands, tens of thousands of these. And after a while, the computer can look at these pixels and start to figure things out on its own. And that's how AWS facial recognition works. It's how they all work. And I started sending these genealogy things to these pictures to AWS. And in the beginning, and again, if you've never seen this, this looks like craziness, but basically this is the bounding box, top, left, right, height, and width. And these are all from 0 to 1. They just scale it. And the search face confidence, basically saying they have 100% confidence that they found a face. Blank brackets means they found nobody. So, but it was at least intriguing that it would work. And then I sent the mother's picture. And the mother's picture found a match, which is super cool. So what recognition does is it gives me what's called a similarity index. I'll talk about that in a second, but the most important thing is it found a match. You can see it gives me information here. And the important thing is that it gives you two figures. Gives you what's called a similarity index. This is a scale from 0 to 100 of how similar my search query image is to the one that it found, which is Rivka Gross, which you will see in a minute, which was a passport application. I'll show you this in a second. And then it will show me a confidence value. And you have to be super careful because these numbers are often similar. The confidence value of Rivka, this is the confidence value, similar to what you saw a moment ago with the father, is simply saying, yes, I found a face on this mysterious woman. That's here, 99.999. And this was the confidence level of whenever I sent in the picture of Rivka Gross. So this is the confidence of Rivka Gross. This is the confidence of Mystery Mother. This is the similarity index between the two. This is the bounding box. It gives them this weird face ID, image ID. But the important thing is because I labeled them properly, I can now know this mystery woman, it's saying is a 97.7% match. It's not really a percentage, but let's treat it as a percentage with Rivka Gross. So let's look at that. So here's the mystery woman, and there's Rivka Gross. And if you stare at that for a second, that is a dead match. Pardon the pun. That is a match. And so what this does is this is the brick wall that you can push through. Once you have this match, then, as you all know from experienced genealogy, then I have a surname, I have a date, I have all sorts of information I can begin searching. And you could start doing your normal family tree things. So, for example, you can go here, and I already knew who Rivka Gross was. I had no idea that that's who Rivka Gross was. But then I didn't know necessarily her husband, and I could look that up because I did this doing more traditional ways. I found a marriage record or whatever, and then I can find the kids, and I could even find the parents. And I did this using traditional search engines, the same stuff you all do every day. But what it did was it gave me a hook. It broke through this brick wall because otherwise you have no way to know where to start. I'm going to go through a different example, but I think what I want to do is I want to pause for a second. Gail, are there any questions? Because I'm in PowerPoint and I don't want to get out of it. So Gail, are there any quick questions that I can answer?
I'd rather leave the questions till the end because,
Perfect.
there are a lot of duplicates. So keep going. And this is cool stuff.
That's great. You're the boss. I just keep on going. So this is a different example. I just want to show you some other ways that you can use this technology. And so I kept playing around. I just thought this was amazing. And I asked Sally Ann, who has been my mentor through all of this. And Sally Ann, I don't know if you're on or not, but thank you so much. You have been an amazing. And Gary Mokotov, who was the editor of my article and was just incredible. So Sally Ann and Gary, if you're there, I thank you profusely for the encouragement, because I don't think I would have had the courage to keep going if it wasn't for them. But I kept playing around, and I tried to push the limits of what this would do. So, for example, this is a Sprinza Geminder, and I said, I wonder what I can do here. So this is a little bit more challenging because the ink stamp crosses her face. And you can imagine facial recognition software is going to struggle with this because it's trying to look for the contrast between the pixels, and it's going to get confused. And I did it once and it did get confused, and I could tell basically what'll happen is when you ask a response, it will not give you what's called a bounding box. And so I wondered what to do, and it turns out it's not that hard. You don't have to make, and I apologize to poor Sprinza here, but you don't have to make her look good. You just have to give it enough to find these landmarks. So if you look here, it looks like somebody did a cruel makeup experiment on poor Sprinza. But the truth of the matter is, all I did was some very simple, paint, Photoshop or whatever tool you use, and I simply darkened the areas that me as a human I could see just enough so that the recognition software would be able to find the bounding box and the landmarks. Again, it's not a beauty contest. I'm not going to put this on my family tree, whatever, but you need to enhance it just enough. Remove and you can actually, if you look careful, you can actually see the ink stamp that I removed there. And like I am not the world's greatest Photoshop person, but you just need just enough. And once you do that, I got a match. And 94% this time, you can start to learn to see these things. So 94% match. And it's saying that it matched it with Sabina Sarah Geminder. And I went, aha. Because the other thing said Sprinza Geminder, Sarah, Sabina, close, born 1917, very close. A lot of people changed their names, nicknames. I'm probably onto something. And then I looked at the picture, and that's the picture from my first slide. And if you look at that carefully, that's the same woman. This is definitely a few years later. And I got an interesting question from a woman who asked me earlier in the day in the other chat room, does it matter that the image is facing forward? And the answer is no. If you'll notice that this picture here, the woman is sort of looking off to the left, whereas this woman is looking forward. And the software actually does literally turn the face. I didn't show it here, but it actually gives you pitch, yaw, and roll, which are the three axes for rotation. And it will actually, in its own computer way, rotate the image to identify the landmarks. It'll notice, by the way, basically that the eyes are not centered, and it will rotate it. It's really quite incredible. And so once I do that, once again, I'm able to get a huge amount of information because I have a dead match here. I shouldn't say it. I have a match. Apologies. I have a match here, and I see Sabina Geminder. I look at the birthdays, 1917, 1918. But maybe I have a sister. It's not clear. There's no perfect answers here, but I definitely have so much more information than I did before. Let me show you one more example before I get to a few more slides and a demo. And again, I want to stop pretty promptly at 6 o'clock my time on Eastern and leave time for Q&A. So Gail, I will stop promptly at 6 p.m. Eastern. I want to show you another example. This is a picture I picked from Yad Vashem. It's really a beautiful picture. I love this picture. I just love this family. I love the looks. There's something about this. But once again, I'm really doing this because I'm trying to help families from Mielec identify. And so this particular image was on Yad Vashem. It was submitted by a Holocaust survivor, Abraham Klagsbrunn, in Israel, as you can see here, for those of you that can read Hebrew. And this is quite common. So Abraham, this is a picture clearly from his family, Klagsbrunn. So you start to glean hints. And for those of you that can read Hebrew, I am now an expert at all, but this is Klagsbrunn, this is Necha. And so what I can do is start to pull things together. So this is Klagsbrunn Necha, 18 years old, and I can go and put her there. And I can see, if you keep reading here, I have two 20 years old, one's Reitzel and one's Shendel, and I can go in those. But Abraham didn't leave me the rest. He just said they all died in the Shoah and so on. So Abraham did not give me everything I needed. And so the rest are unknown. So again, filling in the pieces of a known genealogy problem is really where this stuff shines. So I have Necha, I have Shendel, I have Reitzel, and I have three unknown people. My guess is this is mom. These look like sisters to me. So my feeling is, boy, these two really look like sisters to me, but who knows? And this, I don't know, maybe he's a brother, maybe he's not. He looks pretty happy. I don't know. We'll see. I know what's going to happen. But so what I do is I do the same technique, slice them all into different pieces. Again, these are my three mysteries. These are my three known, although Reitzel, according to the Hebrew, was a friend. So I don't know who she is. And you can actually tell she doesn't look quite the same. And I get a match immediately for these two. And it is, I have to tell you, I went yelling at my wife and I said, it worked. Because that's the match I get for the man. And that's the match I get for the woman. And I'll let you stare at that for a second, because it is mind-blowingly accurate. These images were from those city council identification papers that I saw, that I picked up in Mielec when I was there. These two are from this photo from Yad Vashem. So I'm connecting Yad Vashem with other genealogical records, and I'm able to now identify with very, very high confidence. It is obvious those are the same people. And furthermore, I have all sorts of information. I now know that it's very clear this is a husband and wife. My guess is, I'll show you in a minute, that I guess that this is sort of an engagement or maybe a wedding picture after the wedding, something like this. I now have the photo ID dates and I have the dates of birth, so I can reverse it back and start to do some arithmetic. So for example, I now know that I can go here and start to make a guess. She looks older than her sisters. So I take a guess and say, okay, I know that she was 20. So let's say Kayla's 21, 22. And I know from the previous thing that Moshe was 4 years older than Kayla. So I now can know that, of course, if that's 21, that's 25-ish. I still don't know who mom is. But I can now know, because I know these are born in 1905 and 1909. Now I know when the sisters are born. I now even know that the photo was taken in 1930 or so. So I haven't broken through all my brick walls, but the facial recognition allowed me to break through a tremendous amount. So I want to show you a few more slides, and then I promised I would stop at 6 o'clock sharp. I got about 20 minutes, which is perfect, because that means I can slow a little bit down, and I want to go through a few examples, but I want to explain some back end now that I've whet your appetite on this crazy stuff. You know, it was interesting. I attended a previous webinar earlier today that talked about DNA, and it was an excellent. I don't know if that those folks are on the call, but it was an excellent webinar. If you haven't seen it, you should watch the recording. And I like the way they presented it, where DNA was considered another tool. It's nothing you should use in isolation. It's really something that should complement traditional research methods. And that really resonates with me. I actually built the slide right after their call, after their presentation. Because to me, facial recognition is now just another tool in our toolbox that we have at our disposal, or will have soon, as I'll explain in a minute, to really break through some of these walls where some of you, a lot of us have these walls and we have these pictures. And if we could just get one more piece of information, we could really make a tremendous difference. So I want to get a little bit techie. So I don't really know how many people on the call have a tech background. If you don't have a tech background, this is your time to get a drink of water, because I'm going to go a little deep on the tech side, and then I promise I'll back out. So 5 minutes of pretty tech geek talk, and then I'm going to back out. But this is for the folks on the call who maybe have a technology background and are interested about what's going on under the hood. So if you have a tech background, so these are the commercial off-the-shelf software as a service facial recognition services that are out there. The three big players are AWS Recognition. Azure is called Face, because I guess they can't come up with a more creative name than Face. And then Google has Vision AI. In my opinion, these are all similar. I have not tested Azure and Google. I happen to prefer AWS, but it's not a strong preference. The pros and cons of the pre-trained models. These are, if you are in the tech world, these are easy to use. Again, if you are a tech person, you can access these via the CLI, the command line interface. If you look at my article from Abutenu, I walk through a little bit. I use RapidMiner as my test environment because that's just what I'm familiar with. You don't have to. It's also extremely inexpensive. I mean, it's crazy. So I think AWS allows you to analyze 1,000 images a month for free. And I think it's 0.1 cents per query after that, something like per 100 queries. All I can tell you is that my monthly bill from AWS, having done this since last February with thousands of pictures, is usually around, it's less than $2 a month. It's stupidly cheap. Azure and Google, I'm sure, are similarly priced. Those are the advantages. The disadvantage, and this is the major disadvantage, and I cannot emphasize this enough. I tried to explain earlier, the way that they build these models is they have humans go and point out these visual characteristics of these real pictures, and they have to do it thousands of times, and it's sort of like training a dog. Like if you teach the dog to sit, eventually the dog, if you say sit, the dog will sit. The computer's about the same intelligence, probably less intelligent than a dog. And but they didn't train those, of course, on old pictures of Jews from Eastern Europe or anywhere else in the world. They were trained on contemporaries. They're trained on pictures like you and me. And so these queries we will get what's called false positives. We will get matches, almost like the endogamy problem in DNA. We will get false positives and false negatives because these models were not trained on the pictures that we use. You get a lot more false positives. You also get false negatives. In particular, the problem occurs with women with scheitels. In Mielitz, there must be only one person in all of Mielitz that made all the scheitels, because all the scheitels, sorry, if you don't know what a scheitel is, it's a wig for Orthodox women. And I am sure that there was one woman in Mielitz who made all the scheitels, because they are exactly the same. So, of course, recognition thinks that every woman over the age of 50 or so wearing that particular scheitel is a sister, and they're not. So those are false positives. Same thing with older men with large Orthodox beards. It tends to say those people are the same. So you do get some false positives and false negatives. It also does not recognize babies and small children very well. Those are very strong limitations. The quote-unquote right way to do this from a data science point of view, for those of you in the tech world, is to build your own proper model, to train your own model on your own images. So these are some of the technologies that are available currently. Most people are using TensorFlow. This is SageMaker. This is Keras. This is RapidMiner. There's a bunch of them out there. And but you need to know how to code. And so the pros of it is that if we did this, to my knowledge, no one has ever done this yet. But if we were able to create what we call a training set of thousands of images of people from our ancestors, in the same way at AWS, you can do it. It's just time consuming. It's sort of like indexing with records. You just need time and people to do very mundane work. But that's really all it takes. The technology behind it's very simple, but it's very time consuming. But we would get much, much better results. And also the other limitation, so it takes a long time to build. And the other thing is that right now, these technologies, you really need a data science background. You can't use TensorFlow unless you've been doing this for a while. This is not intended for lay people. So I would say for the time being, we are with the commercial software. But as you saw, the commercial software results are pretty good. I would love to have the time and the energy. And so this gets me to some other things later. But for right now, the commercial off-the-shelf stuff is cheap and it works pretty well. So again, last slide for tech people. Again, this if you're not a tech person, this is going to be a little bit crazy, but some of you may be curious on what's going on under the hood. So in fall 2019, I used RapidMiner, which is the data science company. Full disclaimer, I work for RapidMiner, so I'm very comfortable with it. It's an amazing piece of freemium software. Strongly advise it. That's my little sales pitch. I don't get commission, so there you go. And then, so this is where I did my dev work, where I went back and forth with AWS. I used the command line interface. I could have easily used Python, but I didn't. And I use S3 and recognition. And that's really where I was when I wrote the article in Avotenu back in October or so. And that's really the last that a lot of people saw of my work. The second iteration I'm working on now, and I'm going to show this to you. I'm actually I launched it this week. So almost no one has seen this. It's super cool, I have to say. So this week I launched it on a website, which I'm going to show you in a minute, which allows you to actually not code. But again, I only built this for myself until Sally Ann said, why don't you write an article? I said, okay, but I only did it for Mielit. So I'm showing you this as sort of what we call in tech a proof of concept. So I did this for my website, Mielit. I use WordPress because it's easy. I use JavaScript because it's easy. And I use these other technologies. The Cognito is there simply to do authentication. If and when I have time. So unlike many of you, I'm not retired, so I still have a daytime job. So I do this betwixt and between. I'm on vacation this week, which is super nice. I would like to go and expand this and really start to triangulate this with family tree info. And some of you, your juices are already churning with ideas, and so I have a ton of them, which I'll get to in a minute. But my short-term goal is to I have a new domain called Ancestor Face Match, and I'm hoping to migrate it there. I would continue to build this, but I've had a lot of queries from people saying, can we do this for my town? Can we do this for my town? Can we do this for my shtetl? And of course, the answer is yes, but it's just little old Scott sitting in Vermont. So little by little, we will get there. I also want to talk about some ethical considerations because this is facial recognition. Many of you read the same stuff I do in the news, and particularly with a new technology, I think Silicon Valley is not always good at really trying to look at ethical decisions before doing something. Silicon Valley has this tremendous tendency to, as they say, it's a shoot, what is it, a fire ready aim, right? So I think before we start going a little crazy, I think it's worth it for the genealogy community, particularly the Jewish genealogy community, for reasons that I do not need to explain to this audience. I think we need to take a bit of a step back or a pause before we start deploying this in all sorts of things. And I'm talking to the commercial companies as well as us civilians on some ethical thoughts that I think we should have prior to really deploying this in a larger scale. These are some of the things that sit on my mind. There may be many others. One is, are we risking the privacy of our descendants? In my opinion, no more than any other online records. But with faces, it could be something we want to think about. This one does concern me. So, for example, if they have a picture of me, can some nefarious person take a picture of me and then, knowing that there's this online database of Jews and their images, go, oh, Scott's Jewish? Well, you kind of look at me and figure out I'm Jewish. But anyway, it's a long story. So, but I think that's a concern. I think that's a very legitimate concern, and I think we should go and proceed thoughtfully. Anybody with any tech background can go take a picture of you and do facial recognition. It takes 10 seconds if you have a tech background. So do we really want to give those keys to the store without some safeguards? And similarly, there was just recently in the United States, for those of you that follow, there was a controversy that took place during this election cycle with a man running for Congress. I don't know if some of you follow the news, where it's supposedly a true story. I hope it's not, but I believe it is. That somebody took Photoshop and elongated his nose, which just turns my stomach. But my point is, if we start going down this road of technologies, are we going to exacerbate this issue by basically giving coordinates of landmarks of noses and whatever? I don't know. Those are for people smarter than me and people that maybe study technology ethics. But I want to say that as somebody who's been working on this absolutely on the cutting edge, let's proceed with caution. And so, even things like, people, can we use this at a photo booth in my grandson's bar mitzvah? This kind of thing. So, yeah, great idea. The Tumblr would probably love it. but let's proceed with caution. Okay. Got about 10 minutes left before I go to Q&A. It's perfect timing. I want to do a live demonstration, which has been launched this week. So I'm super excited to show this to you all. So you are the first. Oh, I did a feature wish list. And let's do the demo first. That's no fun. So I'm going to go out of here. You're probably looking at yourselves or me. Gail, can I do a very quick check? Can you see my Chrome browser?
Yes.
Excellent. Thank you, Gail. Hopefully I didn't put you to sleep. Okay, great.
Nope.
I do presentations for a living. So I'm not, if you're all sleeping, that's fine. It's 5 o'clock in the evening. So this is my website, Mielitz Yidden. I don't really, this is just my private website I did to go and put a lot of stuff from Mielitz here. But this week I did port this technology to a live website. And so I'd like to show it to you. It's super cool. I launched it initially to my little inside Facebook group of people that are researching Mielitz, the private group. If you do have families from Mielitz, it's Mein Shtetl Mielitz. You can look it up on Facebook. It's a great group of amazing people. And I've been corresponding with this man from Argentina, where his family members left Mielitz and went to Buenos Aires. Very similar story that many people have heard. And so Jorge Padua is his name. He's a lovely man. And he tested this out. I'm going to show you what Jorge did. This was this week. So Jorge took a picture of his, I think it's his grandmother's great-grandmother, Untitled Chapter, and he put it in there. And I've already entered Untitled Chapter, so now it's pretty easy to use. Well, that's not terribly useful. Let's go to my desktop here. And so all he did, and by the way, this is now a public website. He just simply uploads Untitled Chapter, and immediately results appear like magic on the bottom. It's so cool. I could do this all day long. And he gave him 3 results. One is his original image. And to me, we call this a proof of concept. Simply, it's matching. And just so you know, the computer's not cheating. It's not reading the text, I promise you. It's taking this image, breaking this into pixels, and matching it pixel by pixel using algorithms. And it found, of course, 100% similarity with his original picture. That's not a great surprise. But it also found the passport picture that Jorge had given me before of the same woman with a 93.79% match. Now, I'd like to show that to you just to show you that these pictures are not exactly the same, but when the computer measures the landmarks, it does find it. So if you click on these, you can now see this nice and large. So this is Jorge's original picture of his, I believe, his great-grandmother. And this is the passport picture. By the way, you'll notice I didn't crop it. You don't need to. It's useful, but you don't have to. So, and you can see, but again, if I go back, there's the passport picture. And there's the grandmother. And boy, if you put those side by side, it's the same person, but boy, I would have never done it. But it's that, but we know this is the same person. So again, this is proof of concept. And there was a third result. Again, this is the brick wall that just comes tumbling down. It's so amazing. This is somebody he's never heard of before. But this is Reisel Geminder, daughter of Hannah and Tamar Padua, from a Mielitz ID application. And he goes, oh, we have Geminders in Buenos Aires, Tamar Padua. And all of a sudden, he has still no idea who this is, but we are both convinced that this is a cousin of some kind. And he is now like running around to every archive in Buenos Aires, connecting these dots. But what I have done is helped him move to a whole new branch of family tree he never knew existed, just like DNA. I think that's pretty neat. I want to show you a couple more demos. I want to show you my grandfather because I just think he's sort of neat. Actually, this is a picture of my grandfather. This is Leo Genzer. And these are his 3 sisters who all came from Mielitz. So this is Leo. These are his 3 sisters. And when I started doing genealogy, my father, of course, I said, Dad, who are these pictures? He's like, oh, those are my aunts. Thanks, Dad. Which one? I don't know. Great. Thanks, Dad. Okay, this is Opa. Yes, I know. But who are the sisters? Oh, I think that's Tanta Sarah. Yeah. So this is the world we all live in, right? So I want to show you how you could do this from a straight picture. So again, I'm going to do this live demo. I'm going to take my picture of Leo. I'm just going to duplicate it here. I'm going to make a copy. And I'm going to go and just draw a box around this sister here, which is one of Opa's sisters. And I'm using Preview on a Mac. It's very easy on a PC as well. And I'm just going to rename this super fast. This is like Leo Genzer. It doesn't matter. The image is going to get deleted anyway. I don't know why I bother changing the name. Leo's sister. Oh, Leo. Oh, no, Scott. Come on. Live demo. Leo's sister. Oh, no, don't use punctuation. Bad idea, Scott. Let's do Leo's sister. Good idea. Okay, so there it is. And all I'm going to do here is do Leo's sister and open. By the way, this is exactly the same thing I used to do with RapidMiner and a lot of command line, but I've just coded it into JavaScript, so it's now live on a website. And watch this. Boom. Takes milliseconds. And that's Sarah Genzer. Those are 5 different pictures that I had previously uploaded of Sarah Genzer, who was my great aunt. That's the original picture, which is none of the above. And just to show you, I can show you side by side if I have a half a brain cell at this time in the evening. If I do this, and if I do this, which I tested earlier. Yes, nicely done, Scott. So there's the picture there. And if I go here, you can look side by side. That's definitely her at different stages of her life. She's a beautiful lady, and my father said she loved her very much. So he was super happy to see this. And he, of course, afterwards, he's like, "Oh yeah, that was Sarah." Like, thanks, Dad. Much appreciated. So I'll show you one more demo, and then I'll be just at 6 o'clock, and I'll be ready for questions, Gail. So one more. I would like to show you one that I'm still working on. This one I have not figured out yet, but just to show you again how I do it. So I'm starting from a plain picture. This is another portrait picture from Mielec, from the same museum that I work with. These friends of mine in Poland who have just been incredible to share me these archives. It's a gorgeous picture. I love the boy in the sailor suit. I love him. He is so not happy to be there. And I'm just going to duplicate this. And again, I'm just going to highlight one person. I'm going to highlight the woman only because I know it works. And I'm just going to go unknown woman. And again, once you start doing this more, you'll start getting in the habit of labeling these images. And I'm just going to cut that out. And by the way, I'll just say briefly, some of you may ask, what happens if you don't cut it? What happens if you just send the picture? And the answer is that recognition will find the largest face in the image and will use that one. So if I didn't crop her out, recognition by my eyeball would probably use the father. Just in case you were wondering that. So let me redo that crop here, save this. And once again, all I got to do now is choose file, open, and then poof. This is the proof of concept. I had already uploaded this picture. And these are now the avenues I'm examining, is whether she was possibly a trumpeter, Tova. It's possible, born 1899. It's not bad. This is clearly, she's wearing a sheitel here. It's definitely a different kind of sheitel. I'm not convinced it's her. It's only a 91. By the way, you'll notice these numbers are only 90% and higher. That's because when I coded this, I set the threshold at 90%. Otherwise, I tend to see a lot of false positives. This does not, to me, look the same. Again, I told you before that the computer AWS recognition tends to give me a pretty high false positive rate with women with sheitels. Like this is a pretty fancy one here. Even that is a sheitel, probably is, but pretty fancy one. This was the more traditional one that I think all the women in Mielec wore. Same with this one here, very similar style. I'm not convinced that's the same woman. So is this, the world's end BN? No, it's just like DNA. It is another angle to go around brick walls. So let me just quickly go back to my PowerPoint. I think I'm running right on time. And feature wish list. So once I started doing this, of course, everybody starts asking for more and more and more and more. So as I mentioned earlier, the things that are really top of my list are to build a custom model based on our ancestors. AWS and Google and Microsoft did not build their models based on us, on our ancestors. They built it on us, actually. I would like to start linking this to family trees. Everybody on this call is probably saying, what about my town? What about my town? What about my town? And the answer is yes. But I can't do that myself. My wife would murder me. So, and I'd probably lose my job. So this is a call for collaborators. I don't need people to know how to code, although if you do know how to code, that would be helpful as well. But it's really to start similar projects like indexing. It would be indexing photos instead of vital records. That is my presentation. It is 6 o'clock on the dot, and I'd be happy for Q&A. Gail, I turn this over to you.
Well, you certainly have piqued everybody's interest because there are lots of questions. And I'll start with the first one is, about going back to the Rivka Gross photos. They're an amazing match, look-alike, but it looks like they're horizontally inverted. Is it
Ah,
possible that one is an incorrect mirror image of the same person? If so, which one is real? Does the AI address that
flip it
possibility?
around. It's a totally valid question, and one that I have pondered myself. The honest answer is I do not know. That is my honest
Okay.
answer, is I do not know. I have pondered that question myself, and I even had a moment of panic because, when the software gives me left eye and right eye, is it giving me the left eye and right eye from the person's perspective or from my perspective? It took me a while to figure this out. It's from my perspective, not from the person who's photographed. It's from the
Yeah.
photographer's perspective, which is
Yeah.
weird, by the way. I would do it the other way around, but anyway, whatever. But the honest answer is I do not know that answer.
Okay. Um, okay, we have many questions about what if you don't have a large collection of photos? How many photos do you need? What's a lot of photos? How many in your initial database?
Great question. Yeah, all
So,
good questions, all similar. So you don't really need a lot to start. I mean, if you have 4 pictures and you just want to see whether one matches the other 3, you can do it. It's just a very limited use. But if that's your brick wall, um, if all you need to do is you have one mystery person and 3 other people that sort of look right to you and you just want the computer to double check, you can certainly do it. And there's no reason why not. The larger the set of pictures, the more useful it is, the more people you can find. But there's no reason the software doesn't work any better or worse depending on the number of people you have. They've already built the models.
mhm.
That's very different, by the way, than when, as I mentioned, my wish list, my dream world is that we in the Jewish genealogical community build our own models, which would be better, as I explained earlier, because it would take into account the hairstyles and faces of the era and so on. But in order to do that, we would need a training set. And the answer, Gail, to that is if we want to build our custom models, we would probably need, off the top of my head, 10,000, 15,000 photographs.
Ah, um, somebody wanted to know, you mentioned the software you use for your family tree. What was that? What was that software?
Oh, for my family tree, I use Reunion, which is for the Mac. I've been using it for 20 years.
Yeah.
I don't work for
Okay.
Reunion, but I love it.
Yeah, so somebody said something, and the question said something reunion. So you
Yeah,
answered it.
yeah.
Yes.
Reunion
Okay.
is the only one I know that's custom built for the Mac. The
Mhm.
rest of them are sort of PC based. They're all pretty much the same. But Reunion's been there forever, but I have to say, and I'm a tech guy, so I'm very critical if stuff gets bugs. I have to say, I don't work for the company. If you're listening, I'd love a free license. Don't get me wrong, but I have almost. I mean, I find bugs, but it's really good piece of software.
Yeah, well, as long as you can, export your GED file when you need it,
That's
it's
right.
good.
And if you go to my website, actually, I do not allow general access, but I actually have a family tree that I keep there, which has been ported to the web. And Reunion will export an entire website for me with one click. And all I do
Mm.
is upload that to GoDaddy, who's my host. And I can put my whole genealogy tree online. Again, I keep that behind a
Yeah.
password portal.
Okay, we have a few questions about people want to know what do you mean by cutting the pictures? I don't think not everybody's familiar with that technique. So can you
Sure.
explain that?
Of course, super easy. And by the way, I'm going to show it to you on a Mac. PCs, I know they have the same tools. I'm not a PC guy. I can't stand the things, but I know there are people who know how to do this on a PC. I'm going to show you on a Mac, but the basic idea is exactly the same. So let's go back to my. You can't see my screen, Scott. You dummy. Let me share my screen again.
Yeah, in PC, I use the snipping tool.
Yeah, they're all the same
And there
idea.
are others.
Yeah.
That's the one that comes with Windows. I'm certain there are others that you can freebies and also things you can purchase.
Yeah. So again, thank you, Gail. I know there are ways out there. There's tons of them out there. So I'm just going to show you on a Mac. But again, I know there are tools available for a PC.
Oh yeah.
So all I do is I use Preview, and it's so easy. They have crosshairs, as you can see here. So if I want to cut a picture of my grandfather, I simply draw a box around him. I mean, sorry, I do this super fast because I've done this hundreds of times. But you just do crop and save.
Yeah, the Windows tool is pretty much identical.
Yeah, yeah. So
Um,
that's really it. Let me stop sharing again. Hopefully that answered that person's question.
I believe so. Okay, how does this take into effect aging, photos of the person when they're young and when they're older?
So that's a really good question. The answer is, and again, I'm only telling you anecdotally. I've never actually spent the time to analyze this properly. That's a really great question. The answer is I cannot give you hard statistical evidence. By the way, if I'm bouncing, it's because my laptop is actually on my lap. So it's not your image, it's just my lap. Because I'm Jewish and I talk with my hands. And anyway, so the answer is anecdotally, I can tell you I've been doing this for a year or so. Once somebody's about a teenager, I mean, it's sort of common sense. Like once their face sort of starts to look the same, like I have seen a good 20, 30 year span where the software recognizes it from like age 20 to 50 is no problem. It nails it. Once you become sort of elderly, it's not so good. I mean, it's the same way. Like if you look at baby, like if you looked at a baby picture of me, you wouldn't recognize me. Thank God. I was an ugly baby. But I would say, Gail, it's the same kind of thing as a human. It doesn't do any better or worse. That's purely anecdotal experience. I have not done any statistical analyses.
Okay, the next question, have you used this in conjunction with DNA?
Not yet. No.
Not yet.
Again, that's on my long wish list. If I had all the time in the world, man, I would be so much farther ahead. But like, I'm on vacation this week, so I'm able to go and work on my website and this kind of thing. So, the answer is, yeah, it's on my wish list.
Okay, now we have a question. This is, I should say the people's names. This is from Lane, who wants to know, if I put a picture of myself in the database, will it find people who look like me and could possibly be a relative?
Possibly. So that's sort of in the DNA world, right? So I could tell you this. The answer is, again, I am in the very early stages of this. I'm really presenting this as absolutely cutting bleeding edge. According to Sally Ann, who's been in this business longer than most of us, she has not seen other people doing this. So according to Sally Ann, not me, this is sort of on the bleeding edge. So we're all sort of learning as we go. I put a picture of myself. It doesn't match with any one of my grandparents. My wife was asking me last night, did you put your dad up? And I was like, no, I just haven't gotten around to it. You got to understand, I built this website this week. So before I was using other tools. So I try to do it when I can in between my day job. So the answer is, Gail, those are all great questions. I think there's the kinds of things where we need to figure this out for ourselves. It's too early.
Okay. The next question.
Oh, Gail, maybe I lost you. Did everybody else lose Gail?
Yeah, it does look like we lost Gail.
We lost Gail. I hope she's okay. All right, I'm just going to read the chat window reverse until Gail comes back. Gail disappeared. Okay. Yes, mine steht on the Facebook page. Looks like somebody found my page. Yes, it's the bleeding edge of genealogy. Theory behind matching people at different ages. Their points of the face don't change. Yes, exactly, Mindy Kaplan. I agree completely. Do you want town leaders to volunteer if they have databases with 1,000 pictures to test your software on the sites? Maybe not all of them at the same time. It's only me. So maybe a couple of you. Maybe some of you are more tech savvy. Sure, but maybe not all simultaneously because I may have a Jewish panic attack and hide under my covers. Download Ancestry. What are the labeling best practices? Yeah, don't use spaces, don't use formatting, don't use colons, semicolons. Tech guys will, tech folks, I would say guys, by the way, a lot of women in this business, I apologize. A lot of tech folks will use underscores, tends to be common. Don't use colons, parentheses, just a bad idea. And you'll notice I'm only using JPEGs. Again, it tends to be the standard. Sometimes they use PNG, some they use TIFFs. All right, I'm scrolling up because we lost Gail. I love Reunion for Mac. So do I, Dan. I'm great with tech, but hate teaching. I was a former teacher. What databases the AWS and other tools use? That's a gross. So there's a good tech question. Sandra Jacobson, thank you. So with recognition, you don't need to actually build a database. Actually, it's simply a bucket. It's simply like a folder in your hard drive. It's what they call a bucket. It's what they call a persistent repository in AWS. So it's simply it's really nothing more than Dropbox or Google Cloud. Same thing. It's just AWS. So all you got to do is sign up for AWS. It's cheap as dirt. And start dumping your folders into what they call these buckets. It's called S3. Simple something storage. I don't know. I can't remember what it's called. Simple steady storage, something like that. I can never remember. Everybody calls it S3. They're buckets. You sign on. It's basically free and upload. So it's not a database. AWS does have databases. If you're a database person, I don't know if you're a DB database person. If you're a tech person, Sandra, if you are, AWS has the whole range from Postgres to NoSQL to MongoDB and all this stuff that I'm not going to get into right now. Code based on specs for your family or what you use to set parameters. No, it's generic code. Matter of fact, I've actually set it as Creative Commons public. So anybody who's out there who's a coder, you are welcome to take it, and please just give attribution if you don't mind, just because if my mother was still alive, she would want my name to be in there. So it's a Jewish guilt thing. I'm just guilting you. That's all I'm doing. It's all right. I stand outside in the rain. If you don't put my name, I'll just stand outside. What can I tell you? So the code is there. I know, I'm a comedian. My mother always said so. So if I share my screen again, come on, Scott, you can do this. You work in tech. Share screen. Okay, there we go. So again, hopefully you can see my screen. So if on my page here, if you're a tech person, all you got to do is go and just grab the code. It's there. So here's all the JavaScripts here. You can go to the sources. You can there's my CSS. There's my page. I use Lightbox. It's built on WordPress. Everything's public. The only thing is I do ask somewhere, I do have a comment in here for attribution. I can't find it right now because I can never find it. But if you don't mind giving attribution to me in the code, I'd appreciate it. But I'm not going to get into this whole thing. I'm big on open source and sharing. So you're welcome to it. Yeah, I know. 6:14, Gail. I know. Time's tight. We got time for my clock. I got 2.5 more minutes. Oh, Tara Solomon, you're a blessing. My mother would be so proud. Anybody else? I got a minute or so for questions. I'll tell you what, there's this other chat thing in IAJGS. It's the one that you join conversation. It's the button next to the one for those of you who, like me, are like, what the hell is with this interface? So there was a join webinar and there was a join interface. Join discussion. If you go there, I've been having this nice conversation with this woman named Andrea all day. I will be monitoring that. So feel free to go back and forth with me for the rest of the conference. Gail?
I'm back. Can you hear me?
I can now. You're back.
Yeah, I don't know what I by mistake I went to do something and I closed my browser window, and then when I came back it wasn't working, but the tech guy fixed me, so thank you very much. But we have another minute.
We have another minute.
But this has been excellent.
I could tell more Jewish jokes, but I have a feeling that it's probably time to stop. That's when my mother would say it's time to stop. So being a good Jewish boy, I say thank you very much. I appreciate all the kind words. Please reach out. Just reach out slowly. Thank you.
Yeah, somebody wanted you to list your website again.
Oh, yeah. My bad. Screen sharing. I think it's actually on my bio on IAJGS, but
okay, if it's there, then that's good. Then
all right. So there's my website. It's mielitzYidden.org. If you just search Mielitz Jews on Google, you'll probably find me.
Okay. Well, thank you very much, everybody. This was a great presentation. Thanks for attending. Don't forget to rate it.
Oh, yeah. Good. Jewish Guilt, please rate. Thank you.